Hey everybody, in this video we are going to do what we just did in the last one. We are working on an intro to inverses. We are focusing on some algebraic inverses to start. The last example we took care of a function that ended up being one-to-one and its inverse was also a function. Here we're going to kind of contrast that and we're going to see an example that is not one-to-one and its inverse will not be a function. So let's get started. So find the inverse of f of x algebraically. So the first thing I'm going to do is I'm going to rewrite this time the f of x as y because some people find that to be a little bit more comfortable to get started. Now, in order to find the inverse, we are swapping entirely the domain and range. So like the entire positive x and y axes trade places, the entire positive x and y axes trade places. The whole graph sort of twists and ends up reflecting over the identity function y equals x in the process. So I'm going to do that, and as I described to my classes, and as I describe every year to my classes, when you switch x and y in an equation, it's like you have yourself a little shop, right? La la la, and it had two doorways, and one of these is the entrance and the other is the exit, right? But because of the way that you rearrange the stuff inside of your store, you decide that it's going to be better if we kind of switch it around and we make this the entrance and this the exit. Well, what do we do to make that happen? All you got to do is swap the signs above the door. And then one says in, the other says out, one says entrance, the other says exit. Well, people just follow the sign. The sign will really dictate traffic, and it's going to direct everyone of where exactly to go. And that is what switching x and y does. It's really redirecting your traffic, and it's telling everyone to go here if you're an input, go there if you're an output. And in that process, the entire graph ends up reflecting over the line y equals x. So hopefully that explanation helped some of you. But x plus 7, I'm adding 7 to the other side. For a little bit more chat about it, you could go to the last video. We're just going to get moving. Equals the quantity of y minus 3 squared. Now, I'm going to do the inverse operation right now, which is to take a square root. When you are the one taking the square root yourself, you must put plus minus on the outside. We err on the side of caution. Okay? We err on the side of caution, and we find all possible outcomes. And that's what doing the plus minus does. I'm stressing this because when we get to doing trig inverse, we're going to discuss when we find all possible outcomes and when we find one distinct specific outcome. Okay, so I'm highlighting this now because this is what we call foreshadowing, I believe, in your English class, yes? So that's what we're doing right now. Anyhow, now the square root and the square are gonzo because they undo each other. I'm going to rearrange it while I'm at it. So y minus 3 alone, and I have plus and minus the square root of x plus 7. Last thing I'm going to do is I'm going to take that minus 3 and I'm going to add 3 to both sides. So that minus 3, I'm just saving some space here, becomes a plus 3 right over there. So there's the inverse, found it algebraically. Boom, and we're done. Now it says for us to graph both f of x and its inverse, and I will be color coordinating like this. So I have this guy right here. It's a quadratic equation which has a graph known as a parabola. We are right 3 units. We are down 3, 6, 7 units. There is no stretch or compression, so we will follow the regular pattern that we're used to. Out 1, up 1, out 1, and up 3. Again, if you need help with graphing, I suggest you go to a graphing playlist. Out 1, up 5 is next. 1, 2, 3, 4, 5. And then out 1, up 7, 5, 6, 7. And there we go. All right, so beautiful. Best thing you ever drew in your life. The best parabola ever. Okay. There we go, is our red and done. Now for the blue, left 7 3, 6, 7, up 3. Now, this is really if you remember, we graphed the square root function, and that looks something like this. But if we had a negative in front of that square root function, it looks something like this because it had a vertical reflection. So when we have plus minus, we really have two functions at the same time. So up 1 over 1, up 1 over 3, up 1 over 5, up 1 over 7. So here is the positive square root function. And now the negative, down 1 over 1, down 1 over 3, down 1 over 5, down 1 over 7. So here's the other function, two separate functions. And think about that. Like, you probably just do things, it becomes almost cliche. You just keep going with the flow and you don't really think about the vocab or why we do what we do and this and that and the other thing, right? So here we go. We just graphed the plus minus equation right there. So done and done. Oops. And done. All right. Is f of x 1 to 1? So f of x was the red. 1 to 1 means does it pass the vertical line test and the horizontal line test? While it does pass the vertical line test, it fails the vertical line test. So what does that tell me? Is the inverse a function? No, it is not. Okay? No, it's not, because it fails the vertical line test, right? We still have that symmetry over the identity function, but not a function. Now, the domain and range of these equations, if you notice here, I name the secondary one the inverse equation, right? The blue one. And the red one over here is the original function f of x. So I'm not naming it f inverse of x this time. The domain of the red parabola was all real numbers. That would be negative infinity to infinity. That ended up becoming the range of my inverse equation. So that blue graph right there, the range from bottom to top is all real numbers. Negative infinity to infinity. The range of f of x, that's the red graph right there. We were down 7, so it starts down at negative 7 and it works its way up till positive infinity. And that ends up being the domain of my inverse equation from negative 7 with the bracket, including the negative 7, until infinity. Now, just a quick discussion because this is important. Compare and contrast the inverse of f of x with g of x equals square root of x. All right, so here, f of x equals x squared was this guy. When I found the inverse, right, we got y equals plus minus the square root of x. Graphically, it is essentially something like this. It is not a function. Now, this guy here, g of x, we named it a function. It's g of x. That notation's only for functions, and that is square root x. There's no plus minus. It is just, not my best drawing, but just a sketch, the top half right there. Now, find and graph the inverse of g of x. Okay, so we see a little bit here. Now we're going to find the inverse. So if this is really y equals the square root of x, and I want to switch x and y and solve for y, then I'm going to start off with x equals square root of y. I'm going to square both sides, so I have x squared equals y. So I found the inverse right there in orange, but we're going to graph them. So let's graph the green, up 1 over 1, up 1 over 3, up 1 over 5. So the green. Now for the orange. It's a parabola, you would think. However, it is only the right side of the parabola because its domain and range is dictated by the domain and range of the function we started with. So down over here, let's just kind of jot it down, cleaning up some space for us. What are the domain and range of these over here? So first in green, oh, that is not what I wanted. First, the domain of the square root graph was bracket 0 to infinity. And the range was, well, also 0 until infinity, coincidentally. That means for the inverse, the domain will be only 0 to infinity. It is not negative infinity to infinity like a regular looking parabola. And the range will similarly be 0 to infinity. That came from there, and that came from there. So think about that. Let that marinate. Let that sink in. That is the end of this video. Next up, we are going to actually derive the sine inverse function. So buckle up, and I will see you over there. If you are pleased with yourself right now because you feel smarter and you have a better understanding, thanks so much. You're welcome so much. Thumbs up. If not, go ahead, give it a thumbs down. But I will see you in the next video with sine inverse. So let's go. Adios.